Hello learners, welcome to the today's topic. Our today's topic is of tree module. So that is classification by decision tree, induction and basics. I am Priyanka Gupta. I am working as assistant professor in Department of Computer Science and Engineering, Data Science at Institute of Aeronautical Engineering, Hyderabad. So I am going to cover the topics today. I'll tell about what is classification, what is prediction, what is the difference between them, why the classification is going to be used and why prediction is going to be used. And then we will go into the what is basically classification, because this module is based on the classification model. Then we will cover the decision tree induction. What is decision tree and what are the different important terminology about that. And then we will cover the how to construct a decision tree and how to represent that. Let's start. Classification and prediction. So as we know, databases are very rich to cover all the data around that. So that database also having the hidden information, right? So that hidden information we are using in data warehousing. While we are going to make a data warehouse, on the basis of that we are going to use that hidden information, that is the past information of the data. So we will use that in a useful manner. We are going to predict about some of the intelligent business decisions. We are going to make some beautiful decisions on the basis of that. So that as we know that there will be the hidden information on that. And second is the classification and predictions we are going to use to predict about something for the future trends. So these are the two forms of data analysis. These are the two types of data analysis is there we are going to do. So that can be used to extract the model, that is going to extract the model that is going to describe important data classes. Data classes we can say that is going to predict the future data trends. What is the future data trends will be there, right? So basically the classification is the process of finding. The classification is the process of finding a model, a good model that describes the data class, we can say concepts, and the purpose of this classification is that it is going to predict the class as well as objects. So it is going to predict the class of objects whose class level we don't know, that is unknown to us. So for that we are going to use the known class labels. So that is basically the classification. So as we have seen, the classification is nothing but that is the process that is going to predict the class of objects on the basis of the class labels that is unknown. So whereas the class labels, the classification is going to classify, that is going to predict about the categorical labels. But on the other hand, the prediction that is basically based on the continuous valued functions of values. So that these are the difference between the classification and prediction. So now we will go into the classification. So that module that is completely based on the classification. So for example, if we will take the example of classification, so a classification model may be built to predict the expenditure of some of the potential users. So that type of potential user, they are going to use the computer equipment given their. How we will going to predict the known class level, that is income and that is occupation. So we have to predict about the unknown class labels on the basis of known class labels, right? That is the past data, right? So the classification example that is basically based on that. So in the simple words, we can say we can think of classification as categorizing. So the classification is nothing but that is categorizing the incoming new data based on our current as well as on future data. So that we have made, we have stored in the database that is already with us. That is already we know about that data. So the basic techniques for data classification will be such as the decision tree as well as Bayesian classification, Bayesian belief networks, and the neural networks. So these are the few classifiers are there, few techniques are there to do the classification on the on the different terms. So data classification basically is two-step process. So first process will be the learning. What is learning basically? Learning is nothing but learning is basically that we have to train the model on the basis of the past data or current data. So that is basically the learning. Second phase is the classification. Classification is nothing but on that we have to build a model that is going to predict about the new class levels, right? So in the first step, a model is built describing a predetermined set of class objects as well as the concept and classes. So the first step, I have said that learning. So the training data will be used there. So what is training data? Training data is nothing but that data that is already stored there, that is the past data, and as well as the current data that is particular that is coming from the different live streams. So that we can say that is also will be considered as a training data. So training data will be analyzed by a classification algorithm. So we are going to use some of the classification algorithm to classify to do the prediction. So here the class labels attribute suppose is the credit rating. So suppose example is there, the customer is there who is using the credit card. So we are going to use the one class label that is credit rating. So on the basis of credit rating, we are going to predict about how the customer is going to that particular item. He is not going to buy that particular item. So the learned model or classifier will be represented by the some of the classification rules. So as we are going to use some of the techniques that like decision tree as well as the Bayesian classifier. So that is basically the representation, graphical representation is there. But we are on the basis of that graphical representation, we have to write the some of the rules, some of the classification rules. So that is nothing but we have to write some of the we can say syntaxes that is based on the some rules, if else rule will be there. So we can form as the graphical representation will be there, that will be easy to write the classification rules, right? So that was the learning part. Now the classification part. So the test data will be used there. So what is basically the test data? The data what we are going to about what we are going to predict, the new data. So that will be the test data, testing data, right? So that will be used to estimate the accuracy of the classification if else rule. So in that in this phase, while we are going to predict about some of the unknown class labels, apart from that, we also have to calculate the accuracy of that. What is the error rate of the model? What is the accuracy of model? How the model is going? How accurate the model is going to predict? So there are some of the formula will be there. So we have to calculate some of the fields on that. So that's on the basis of that we will be surely we can say the model is accurate, model is not accurate. So although we can use the error rate, we can also find out how much error is coming while our model is going to predict, right? So the test data is going to use the estimate the accuracy of the classification rules if the accuracy is considered acceptable, right? So the rules can be applied to the classification of new data tuples, new class labels that is constructed by analyzing database tuples, whole of the database tuples that is described by the attributes, right? So like that um, we have to classify, we have to analyze the new data tuples from the whole databases. So what will be the attribute here? So attribute will be there, some of the attribute measures will be there, basically that is going to split the branches onto the classifiers. That is, suppose we are going to use here in this chapter the decision tree. So the decision tree, how the branches is going to be split, on which basis it is going to split. So some of the rules are there, some of the measures are there. So on the basis of that, the splitting will be taken care. So now the each tuple will be assumed to belong to a predefined class. So predefined class is nothing but the class we already know. That is basically we know. So as determined by one of the attribute called as a class level attribute. So that is basically the definition of that. In the context of classification, the data tuple are also referred to as samples, examples, objects. So we can say the class label, right? So the class label is nothing but that can, we also can say that in data tuples, samples, examples, objects, like that. So in the general approach, if we are going to build a classification model, so that will looks like this figure. So this figure is basically that is going to tell about the whole of the classification process. So the data set, the databases, what we know, that will be the training sets. So that will be given to the model, to train the model. Then it will be induced onto the model, that on the basis of that the model is going to learn something, right? So the model is going to learn something. On that model we are also going to apply some of the learning algorithm, right? On the when the training set and algorithm will be applied on the model, that is going to learn something, and that will be the model. Then we will measure the model accuracy, how accurate the model is. There will be some confusion matrix. On the basis of that we are going to measure the accuracy, and then the model will those of the accuracy will be applied on the model, and that is going to predict about the test set. What are the new data tuple is coming, what are the new class levels are coming. So on the basis of that is going to predict about the test sets. So test set is nothing but that some of the classes we don't know. So like if in this training set, if we will see, there is the transaction ID, there is 3 attributes, yes, attribute 1, 2 and 3, and last column is the class. So the class is having the two types of classifiers, no and s. So if for this classification model, we have to predict about the classes. If it is yes, it is no. On the basis of these are the attributes, we are going to predict about the class, the particular transaction which is going to be yes, that is going to be in no class. So like that the prediction will be there. So as the rule is there, the training and test set will be that will be divided into that will be the measurement. So there, that is going to class. A good model will be that the test set will be the 30% and training set will be the 70%. So there are some of the combinations of the good set, how to give the how many data set we have to go into give into the training set, how much data we have to give into the test set. So test set is that will be the good model actually. So that we will discuss about the later classes. So that was the classification model of a overall, how the model is going to predict something about the new data tuples, right? Now, the data tuples analyze to build the model collectively. So that because the all the data tuple that is coming into a way into the training data set, right? So the individual tuple that is making up the training set are referred to as a training samples also, and that is going to be randomly selected from the sample population. So that is a one myth, like one term, because if sample will be there, that is coming from the whole of the overall population. So since the class table of class level of each of the training sample is provided, this step is also known as a supervised learning. So how we are telling that is a supervised learning? Because we are giving that model to training sets, and the basis of training set, the model is going to learn something. The model we have to train about something. So that will be the supervised learning. So that is the learning of the model is supervised, is that it is told to which class each training sample belongs to. So that is the whole description of that. Basically, the supervised class learning is nothing but we are providing the already known class levels, and that is going to predict the unknown class levels. So, in contrast with the unsupervised learning, what is unsupervised learning? That is also called as a clustering. So that is that in which the class level of each training sample is not known, that is unknown. So on the basis of that, we are going to predict. So the number of set of classes to be learned may not be known in advance. Okay. So typically the learned model is represented in the form of classification rules, decision tree, or we can say mathematical formula. So in these three of the representation, we can use these of the learned model. So we can also use is that in the form of classification rules, that we can also that classify into the form of decision tree. We can also represent that into the form of mathematical formula. So for example, if we'll take an example of that, given a database of customer credit information. So if the customer is there who is going to use the, so for example, if a database is there of customer credit information, so the classification rule can be learned by to identify the new classes, new customers, new class levels. So that is having the, so that will be the classify into the two forms or three forms, we can say. So the credit rating can be excellent, that can be fair, that can be poor. So like that, the prediction, that is the prediction is going to classify into the these of the 2 or 3 credit ratings. So the rules can be used, so we can write rules for that. So the rules can be used to categorize future data samples, so as well as to provide a better understanding about the model, that is having the database contents. Decision tree. So we are going to cover the decision tree here. So decision tree is the most powerful and popular tool for classification and prediction. So that is having the tree-like structure, right? In this figure, we can see in the right-hand side, that is having the structure like tree. So a decision tree is flow chart like a tree structure, where each of the internal node that is going to denote the test on the attributes. So that is attribute, and each of the branch that is going to represent the outcome of the test. So what is the outcome after this node is there? So that is going to represent that. And after all each of the leaf node, so that is the leaf node. These are the leaf nodes. That is the terminal node. That is holds a class label. So that was the description of this decision tree. So this decision tree basically is of by computer. So the above decision tree is for by computer, that indicates whether a customer is going to the customer of a company is likely to buy a computer, or he is not likely to buy a computer. Decision tree induction. Decision tree can deal with the both of the categorical as well as the numerical data, right? So these two types of data will be on these type of data, the decision tree can be taken off. That we can represent any type of class labels here. So decision tree induction is the method of learning the decision trees from the training set. So we are providing the training set, and it is going to learn about the decision tree. The training set consists of, that is having the attributes as well as the class labels. So class labels are nothing but that figure we have seen some of the class labels are represented by the nodes that were the class level, and attributes are nothing but that is having the leaf nodes, that is having the leaf node, that was the attributes. So like that, the training set is consisting the attribute and class labels. The applications will be for the decision tree induction, that includes the astronomy. In astronomy we can use that, and the financial analysis we can use that. In medical diagnosis, manufacturing and production unit, we can use the decision tree to represent the new class levels or training data set. It in a flow-like tree structure, the data set will be broken down. So as the main root node were there, right? So first node were there, that is called as a root node. After that, the whole of the class levels will be that will be distributed. So that will be the broken down, that will be splitting onto the branches. So that will be splitting into the smaller subset and is represented in the form of nodes of a tree. So that will be called as a node, right? So that this structure that is having the root node, that was the first node, the root node that is having the internal node. So in that figure we have seen that were some of the nodes were there internally, that was the internal node, and after all the last node were the leaf node, and the in between what was the connecting structure were there, that was the branches of that tree. So the root node is the topmost node that is going to represent the best attribute selected. So from that training set, what will be the best attribute that will be selected as a root node. Then after, the other branches will be splitting. So the internal nodes of the decision node that represent a test of an attribute of the data set. So the leaf node terminal node which represents the classification or decision level, classification level. So the branches that is showing the outcome of the test performed. So the branches, here are the branches, these are the branches, that is going to represent the outcome of the test we are going to perform. So that will be splitting on the basis of the outcome. Thus, some of the decision tree that is having only the binary branches, binary nodes. So that means that exactly two nodes will be there, two branches will be there where the splitting will be happen. So while some of the decision tree that is not having the two binary structure, two nodes. So here in this example, in this right side and head figure, we can see here is the decision tree of Titanic data set that is having the binary branches. So that is having the binary, two of the branches each of the subnodes is having. So that is nothing but the binary structure to understand about this term. So that is also having the non-binary. If you suppose here is the one branch, so that will be the non-binary. So the image shows the decision tree for the Titanic data set that is going to predict whether the passenger is going to survive or he is not going to survive. So here some of the facts are there. On the basis of that, the data set will be going to predict about whether that is all about the passenger who is going to survive or he is not going to survive. Now we are going into the construction of decision tree. So the decision tree can be learned from the splitting the source set into the subset. So that is going to be based on the attribute value selection, attribute value test. So that is the measure the something that on the basis of that particular branch is going to split. So that we are having some formula. So on the basis of that, we are going to split the some of the branches. So this process will be repeated. Actually, this will be iterative in nature. So on the each of the derived subset in a recursive manner, it will be repeatedly happening. So that will call as a recursive partitioning. So the recursion is completed when it will be complete when the subset at a node of the all has the same value. That will have the same value. So again, that is not going to be iterate for the target variable. So we can say when the splitting no longer adding a value to the prediction. So like that, the process will be completing. The construction of data decision tree classifier does not require any prior knowledge, any domain knowledge, any parameter setting. That is only will be based on the unknown class levels, and that will be based on the known class levels, that is going to classify the unknown class levels. So on the known class level, that is the training set, that the data decision tree classifier will be performed. So and therefore is appropriate for exploratory knowledge discovery. So here we are going to discover the some of the knowledge that we don't know about some of the class levels. So for that, we are going to use that decision tree. Decision tree that is going to handle the high dimension data. Basically, the representation basically is used for to represent the to graphically represent some of the high dimension data. Some of the large data will be there. Then we can classify. We can see so is at in the form of decision tree. So that will be easy to understand. So in general, decision tree classifier has a good accuracy because that is using the attribute measure, and on the basis of that, all the branches will be removed. What are the important branches will be there, then only that will be constructed in the decision tree. So decision tree induction is a typical inductive approach to learn about the knowledge on the classification, on the classifier. So decision tree can easily that will be converted into the classification rules. So as we have seen, we can write the classification rules based on the some of the decision tree represented there somewhere. So that will be easy to write the classification rules over there. Now, what is decision tree representation? So basically, the decision tree classify the instances, that is going to sort, and then that is down from the root to some leaf node. So that will be basically the descending order, which provides the classification of the instance. So the instance that will be classified by starting of the root node of the tree. So testing the attribute specified by this node, then we are going to move into the other node that will be down to the root node. So like that, the branches will be branches will be corresponding. The branches will be corresponds. So the branches correspond to the value of the attribute, and then it will be move forward. So in the example figure, we can see that. So this process then will be repeated, and then the subtree of the that will be rooted, and that will be forwarded and added to the new node. So here, right. So here that is the example of this weather. That is the decision tree of weather. So in that, what we were like talking about, that will be subrooted. That will be subrooted accordingly. What were the value will be there? That what were the attribute major value will be there. On the basis of that, the branches will be classified. So like this, the structure will be classified on for the each of the class levels. So the decision tree in the figure, that is classify a particular morning. So that is the morning, that is outlook, that is dividing into the sunny, overcast and rainy weather, right? So according to that, there will be some player. There will be some player. So here on the basis of that, some of the class levels, known class level, we are going to predict about if the weather is suitable or not for to play tennis for that player, and then that is going to return the classification associated with the particular leaf. that is that is resulting into the yes and no onto the branches, right? So if whether the player is going to play or not, he is not going to play. So like this, yes and no, right? So for example, if we will write some classification rules for this decision tree, the same decision tree. So the outlook is, when the outlook is equal to raining, outlook is equal to rain, so this, then temperature is equal to hot. So obviously the rule will be there, temperature will be hot when rain will be there. Then we will write temperature is equal to hot. Then we will write humidity is equal to high. The humidity is equal to high. Humidity is equal to high. Then the wind is equal to strong. Wind will be strong. If the humidity will be high, then wind will be strong. So then the that will be sorted down to the downward leftmost branch. That is the leftmost branch. So that is the no. So the that will be resulting into the leaf node as a no classifier. So that would therefore will be classified as a negative instance. So the player is not going to play in the rainy season if the temperature will be hot and the humidity will be high and windy, the weather will be windy. So the player is not going to play tennis for that season, that particular weather. So like this, we can write some of the classification rules. In the other words, if we write that same classification rule in the form of disjunction and conjunction, so we will see that example. In the other word, we can say that decision tree represent a disjunction of conjunctions. So of the sum of the constraint will be there on the attribute value. So that will be, for example, there is a outlook is equal to sunny, that is concatenating humidity is equal to normal, outlook is equal to overcast, outlook is equal to rain, as well as wind is equal to weak. So the same classification will be written as a in the form of disjunction of conjunctions. So that was all about the decision tree for the classification of model. So here we have covered the what is classification basically, what is prediction, what is classification techniques are there, what are the different classification techniques are there. Here we have taken the decision tree, how we are going to write the association classification rule for that, and how we are going to split the how we are going to represent that particular decision tree for some of the example, and how we are going to construct the decision tree. So that was all about the today's topic. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.